Alrighty, today the next bit, lesson 18, is called Translational Equilibrium. So as this says here, a body's in translational equilibrium when the sum of the forces acting on the body are zero, thus it does not change its position. So if we've got something there sitting there, and it may have a number of forces acting, could be all sorts of directions, but if we add all of those up, sum of the forces equals zero, then if the sum of the forces on that are equal to zero, then it's not going to move in one way or another. Now, examples of that would be, signs and things like that. So here's an example. Alright, so the example says rigid advertising banners to be hung by two guy ropes. The banner's a mass of 45 kilos and the ropes must be at an angle of 30 degrees to the vertical as shown. I'll show you that in a minute. The mass of the ropes is ignored. Determine the tension in each rope required to support the banner. Alright, so it says as shown, this is what it looks like. Alright, so there it is. So here's our sign there, grand opening sale. Its mass 45 kilos. So there would be a weight force acting down. Alright, so there's tension in these ropes. So there's some tension there, some tension there, T. Now, given that these are both at 30 degrees, then the tension in the ropes would be the same. If the angles aren't, then it gets a bit more complicated. So, and if this advertising sign doesn't move, then some of the forces have all got to equal zero. Alright, so if we look at the tension forces, each of them has got a vertical component. And then there's a horizontal component. Alright, so those orange horizontal components are going to balance each other and it's not going to move sideways. Seeing as we don't know the tension, we don't know what those sideways forces might be, so not overly useful to us. However, the vertical ones, these two green ones, in the up direction, well, they're in the opposite direction to our weight force, which is down. So, again, I said because of the symmetry, both those tensions are the same. So, these green ones, well, because they're adjacent to the angle, we're going to use cos for those. So, the tension, so if I'm looking at this one over here on the right, for example, then this tension and the angle, so that then this green one, call it F, will simply be T cos 30. And then of course this green one over here is also T cos 30. And they're up and the weight force is down, so what we have then is that the weight force is equal to 2 lots of T cos 30. Alright, so that's one for each side. Now, weight force, of course, we know is mg, and the mass we were told was 45. G is 9.8, equals 2T cos 30. Alright, so if we then divide both sides by 2 and by cos 30, we find that the tension is 45 times 9.8 over 2 cos 30. That you can stick in your calculator, and when you do that, you find that the tension is 254.6 Newton. Alright, so I've done it slightly different in the notes, but essentially it doesn't matter whether you do it this way or the way I've done it in the notes. You can still get the same answer, of course. Alright, so the key thing here was because of the symmetry, the tension on both sides, the rope is the same. If it's not symmetrical, then that will change slightly, but you still would use the same the same thing here, in that we're using those angles, but the angles different, the tensions might be different. All right, so that's about it. What I've just said about if it's not symmetrical, if you get a question like that and you can't quite figure it out, make sure you give me a yell. I'll come over and help you. So there's some questions there in your text. Have a look at those videos, and of course, if there's anything you're not sure of, make sure you ask.